Hi, my name is Peter Dvorak, and today I'm going to demonstrate how to bring security engineers and developers together with the help of visual code maps. A few words about myself. I'm a technical product leader at AppLand, and I have been building products for developers and technical audiences in startups and small-ish companies for over 15 years. But I'm not busy working on innovative products for developers. I enjoy riding my bikes and playing loud music. These are the main points that I'm going to cover in this presentation, demonstrating how visual code maps recording from security pen tests improve collaboration between security and development teams, and how they can help organizations make their applications safer in a shorter time. Let me introduce the concept of code maps and then jump into a demo. Let me start with a statement. Our current workflow is broken. Security teams are experts at finding design-related security vulnerabilities, particularly those that elude typical code scanning tools. But finding those security flaws is only half of the battle. Developers have to understand the flaw, find the root cause, fix it with a test, and ensure that the code stays fixed. This workflow, find, communicate, fix, and monitor, is broken, and it's leaving companies exposed to harmful attacks and developers left holding the bag. Here's where the problem lies. While security teams already produce a slew of artifacts in an effort to document the vulnerabilities they find, these artifacts are not optimized for developers. It takes far too long for developers to wade through static pen test reports to understand flaws, find the root cause, and implement fixes that won't impact the larger code base later on. And that's time no company can afford to lose, both from the security and engineering resource standpoint. What security and development teams need is a more efficient and productive process for working together. And I'm going to show how they can do this with an AppMap, an open source tool and data framework that records and maps application code as testers probe the application. So what is AppMap? AppMap is like Google Maps for code, and we also call them code maps. The mapping feature shows you how functions, web services, data stores, security, I/O, and dependent services all work together. AppMap is different from many other software intelligence tools you have used because it collects information about how it works and the application runs. AppMap is primarily built for developers. They can use these interactive code maps to quickly orient themselves in unfamiliar code, understand how monolithic applications work, troubleshoot stubborn bugs, or communicate code design updates to their peers during code reviews. All that makes code maps a perfect tool for recording, exploring, and analyzing security vulnerabilities as well. AppMaps make it very easy to spot problematic code or database commands, and then navigate to the root cause, revealing literal blueprints of code flaws in applications. And because recording code maps is simple and automated, they are convenient for other teams to use as well, including the security teams, making them a great technical resource to add to pen test reports. Let me now show how code maps of security vulnerabilities are recorded in action. I'm starting this demo as a security engineer who is performing a pen test. My demo application is the well-known budget store that is riddled with security nightmares in its code. So here is my application. But here is a quick glance at the startup configuration. I'm adding an AppMap recording agent to the startup parameters of the app. The agent can be easily added to any dev or test environment. This is a Java example, but Python, Ruby, JavaScript, and PHP languages are supported in a very similar way. My application is now running and ready for my test. I will record a new code map of my attack with start-stop controls in this web browser extension. Similar recording controls are also available for scripts and in popular code editors. My first test is a simple classic example of reliance on cookies without proper validation of data access. When I open my basket, as an unsigned user, the app creates a new basket for me. There is a new basket ID in a session, and it's set to a value which is larger than 1. Let me set a basket to 1 and see what happens. Yep, I have just accessed someone else's basket. So this concludes my first test. Let me now finish the recording and inspect what has just happened in the code of the application. The recorded AppMap is saved by the extension in AppMap Cloud and opens in a new tab. I can now inspect what code components and what code flows were executed during the test. I can see that there were 2 calls to the basket JSP made during the test. This is the first call. I can see that the new basket record was created in the database, then fetched from the database, and then additional details were fetched for my basket from the database as well. This is the second call. I can see that when the session ID was present, the application went straight to fetching the information about the basket from the database without doing any data access checks. I can now save this AppMap and share the links with my developers as a part of my pentest report. They can open it in their code editors and keep working from there. So let me switch roles now. Let me go to my code editor. And I can see, and I can open the same AppMap as the pentester directly in a code close to my sources. So I can see the AppMap here. When I now inspect the code, I can poke around and match what the AppMap shows with the actual source code. So I can see here what happens when the cookies are present, and that the application fetches the data straight from the database without making any checks, or what happens when a new user is opening a basket and how it's created on his behalf. So this example is intentionally simple, and the code is not pretty nor structured like a real application, but I can apply the same approach for a real application code. I'll show how such an example works in a moment. Before I move to the second demo, let me quickly show examples of app maps of other vulnerabilities that were found in the budget store. This is a recording of SQL injection. I can see how the unsanitized parameters to the login JSP page flow through the JSP functionality all the way to the compromised SQL selects. And here is an example of an app map showing a cross-site request forgery, where unsanitized comment leads to unauthorized access of the change password service, hijacking the administrator's password in the process. This concludes my first demo. And let's move on to the second demo application. My second demo application is the Rails Sample App 6th edition, a very popular resource for mastering the Ruby on Rails framework. It is a modern Twitter-like app that is properly designed, coded, and that also has great test coverage. One of our community members discovered a weakness in the app. If you know the direct URL, you can look up registered users and their details without being authenticated. Here is the application. I'm going to start recording and access the URL directly. When I stop recording, I get an app map, which will show me that the application fetches the registered user's data without any checks for authentication. and access additional information about the user. So as a developer, I can now go and create an automated test that will replicate the problem, record it, create an app map, and compare it to the original app map provided by the pen tester. Here is my code editor for my Ruby application, and I have just written this simple test. The test checks whether the user is logged in, and if not, expected him to be redirected to the login URL. So when I run the test should fail, because at this point, the application returns real data. Okay, the test fails, and I can take a look at the app map, which has been recorded from my test. When I look at the details, I can see that the test is remarkably similar to the test recorded that the app map is similar to the app map recorded from the pen test. The code simply retrieves the user information and then additional details. So I can fix my code now. Rerun the test and see the new results. Well, because I have fat fingers, I have to correct my typing errors. Rerun the test again. Okay, and the test now passes. Because this app map is so similar to the app map recorded by that pen tester, I now have a high degree of confidence that I've actually fixed the reported problem. And then when the pen tester replicates the problem later in my fixed code, he will not be able to do so. So let me look at the app map recorded from the fixed code. As you can see, there are no SQL commands in the code trace anymore. And basically at this point, when the user is not authenticated, the endpoint returns back a redirect to the login page. As a pen tester, I can very quickly verify that new behavior in the application again. So when I reload the app, you see that I no longer see the data, but I'm redirected to the login. I can now attach both app maps with the fix and with the issue to my code review and make it easier for my peers to understand the nature of my fix and make sure that it is well designed for my code base. Okay, let's go back to my presentation. So in this short demo, I have demonstrated how visual code maps can complement existing tools and documentation in the process of discovery, communication, fixing, and reviews of code flaws. So what are the app maps changing in the work of security engineers and developers? As a security engineer, I can complement my report with code maps of my attacks that will help other teams understand how and why my attacks worked. As a developer, a glance at a code map attached to a pen test report quickly reveals that a part of my code is vulnerable, how to build automated tests to replicate the issue, and then I can use the maps to validate that the issue is indeed properly fixed without any side effects. Additionally, after delivering the fix, I can use code maps to document my solution. This will speed up the code reviews, but also work as an example of how to write clean and secure code for others. Thank you for watching my presentation. If you have any questions, please join the Q&A session later. Visit us on appland.com and join our Discord server. We are friendly folks. Goodbye.